Welcome to another high-stakes explainer. Today, we're taking on the role of the ultimate football strategist. But instead of a grass pitch, our arena is the Cambridge 0606 Additional Mathematics exam. Think about it like this. A top-tier football manager doesn't just throw 11 players onto the field and just kind of hope for the best, right? No way. They have a strict formation. They have practiced tactics. They know exactly how to outplay the opposition's defense. While the exam paper, that's your opposition. And those tricky multi-step question barriers, that's the defense. If you go in there without a tactical formation, you are going to get tackled, you'll lose possession, and you are absolutely going to drop marks. But if you execute with precision, you'll break right through to those top-grade boundaries. Okay, let's dive into this and build your elite playbook.
I want you to consider this piece of advice straight from a senior examiner. They said, most students lose easy marks, but after this explainer, you won't be one of them. I really want you to internalize that, because the stakes for mastering additional mathematics literally could not be higher. You know the feeling. When you're sitting in that exam hall, the clock is ticking down, your adrenaline is pumping, the pressure is totally on. But the implication of that quote is fascinating. Students aren't necessarily failing because they don't know the pure math, they're failing because they're losing the easy marks. They are missing wide-open goals. So today, I'm going to show you exactly what examiners are looking for, and we are going to eliminate those unforced errors from your game completely.
To see exactly how this happens, let's compare two very typical student profiles. On one side, we have Alex. Now, Alex is a hard worker who's basically memorized the entire textbook. So when faced with a complex additional math problem, Alex just overloads the page with raw mathematical facts, but provides absolutely zero structured analysis. For instance, Alex might spend 10 agonizing minutes furiously calculating the greatest term or detailing the properties of coefficients in a binomial expansion. But here is the massive red flag, pulled directly from the 0606 syllabus. Knowledge of the greatest term and properties of coefficients is strictly not required. So Alex just wasted precious time and energy attacking a defense that wasn't even on the field. Then, on the other side, we've got Sam. Sam is fast, but Sam is frantic. Sam rushes straight into the numbers and completely misses the command word requirements. If a multi-part question clearly says hence or otherwise, Sam completely ignores the word hence and starts entirely from scratch. Because of that, Sam loses the crucial method marks tied to utilizing the previous section's answer. Both of these approaches are deeply, deeply flawed. Failing to understand examiner expectations is exactly how you bleed out those easy marks. To fix this, we're going to follow a clear cognitive roadmap today. We'll start with the core theoretical architecture, move into the procedural framework, cover those critical examiner alerts and mistakes, and finally, unlock the critical analysis matrix.
Let's kick things off with Section 1, the core theoretical architecture, where we decode exactly what the examiner's assessment objectives actually mean.
The crucial starting point here is understanding the distinct cognitive domains tested by Cambridge. They break these down into knowledge and understanding, application, and analysis. Think of this as your absolute baseline. Yes, you need the algebraic knowledge, obviously, but more importantly, you need to apply it and analyze it within the exact context of the question. Remember our friend Alex from a minute ago? The exam board is testing your ability to apply core principles to new mathematical problems. They are not testing your ability to regurgitate obscure facts that aren't even on the spec anymore. You've got to target your cognitive load exactly where the assessment objectives tell you to.
And here's the secret weapon of the elite student, understanding cross-topic connections. The theoretical architecture of this entire syllabus rests on precise definitions and how they integrate with other areas of the course. The principal examiner reports highlight time and time again that candidates who reference cross-topic connections achieve significantly higher marks. Just isolating mathematical formulas simply won't cut it anymore. You might need to use differentiation to find a stationary point, right? And then immediately pivot over to coordinate geometry to find the equation of a normal? The exam is testing your fluidity. Top-performing students don't look at chapters 1 through 10 as separate, isolated islands. They see them as one deeply connected mathematical continent.
To communicate those connections clearly to the examiner, you need a bulletproof structure. Even in pure mathematics, applying a structured approach, often referred to as the Peel framework, is incredibly powerful for laying out logical proofs and multi-step equations. Now, before we continue breaking down this framework, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, let's look at Peel in a mathematical context. Point means explicitly stating your starting formula or the specific identity you're using.
Evidence is your substitution, literally plugging the known values into your equation. Explanation translates to your algebraic manipulation. You're explaining your logic through clear, step-by-step mathematical operations. And finally, link means linking your final calculated value back to the specific context of the question, verifying if it's the required length, area, or coordinate. By using this structured approach, your answers stop looking like a chaotic jumble of numbers and they start reading like a professional, irrefutable mathematical argument. So, now that we have the theory down, let's transition into the technical methodology phase. This is where we take those harsh red pen marks on your practice papers and transform them into brilliant green check marks. Welcome to Section 2, the procedural framework.
I really want you to treat this 5-step sequence exactly like a pilot's pre-flight checklist. Whenever you tackle an examination question, walk through this procedural framework sequentially. Step 1. Deconstruct the question. What's the exact mathematical command word here? Are you being asked to solve, verify, or show that? It matters. Step 2. Extract relevant data. Pull the specific coefficients, coordinates, or constraints right out of the text. Step 3. Select your analytical framework. Are you utilizing vector geometry, calculus, trigonometry? Lock it in. Step 4. Execute with clear notation. Guys, this is totally non-negotiable in pure math. And Step 5. Present with terminology, making sure your final line directly answers the original prompt. This is exactly how top candidates systematically approach complex problems. They don't panic, they don't just guess, they execute the procedure. Taking just the first 60 seconds to properly deconstruct and extract makes your actual execution phase completely frictionless.
And a massive part of that flawless execution is your presentation. You must adhere to strict presentation conventions. That means using proper headings for different parts of a multi-part question, using the correct mathematical terminology, applying appropriate formats like giving exact trigonometric values when requested instead of messy decimals, and providing clear annotations. The examiner needs to follow your logical flow without struggling to decipher your handwriting or guessing what some randomly appearing variable is supposed to represent. When an examiner sees a beautifully laid out algebraic progression, they're already predisposed to award method marks because your cognitive process is highly visible. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. That brings us perfectly to our next segment. We are now entering the danger zone. Section 3, Examiner Alerts and Mistakes. These are pulled directly from the principal examiner reports, and they are the deadly mathematical traps that catch out thousands of students every single year.
Here is an absolutely crucial examiner alert. Method marks save grades. Show you're working. I honestly cannot stress this enough. Even if your final answer is completely, objectively 100% wrong, the method marks can literally save your entire grade. If you drop a negative sign at the very last second, but your page shows a flawless procedural setup and integration, the examiner is still going to reward you for the correct process. But if you try to do the intermediate algebraic steps in your head or jump straight to a calculator and just write down the wrong final answer, 0 marks. Nothing. You absolutely must make your mathematical thinking visible on the page. Beyond just failing to show the working out, the principal examiner reports have repeatedly identified a highly specific set of recurring errors. In fact, there are exactly 3 major pitfalls that routinely ruin otherwise excellent pure math papers.
Let's quickly count down these top 3 examiner warnings so they really stick in your memory. Number 1. Confusing cause and effect. In a mathematical context, this usually means working backward incorrectly. For example, in a show that proof, students sometimes start with the final answer and try to work backward to the premise. That often results in circular logic, which equals 0 marks. You must start from one side and logically arrive at the other. Number 2, forgetting format and presentation checks. This includes really foundational errors, like completely forgetting the constant of integration, or rounding prematurely in the middle of a calculation, which then completely throws off your final answer. Number 3, answers not specific to the given context. If you're calculating time or length using a quadratic equation and you end up with a negative root, you can't just leave it there. Time and distance cannot be negative in most physical contexts. You have to explicitly state why you are rejecting that root to ground your math in reality.
Let's test this with a quick mental challenge.
Think about two typical student approaches to solving a complex equation. The first student essentially isolated the data. They saw the quadratic, plugged it straight into their calculator, and just wrote down the two final roots. The result? Flawed. The examiner commentary notes they failed to interpret relationships. They didn't show the intermediate factorization or the quadratic formula substitution. The second student, however, provided evidence-based conclusions. They wrote out the full algebraic manipulation step by step, showing exactly how they arrived at the roots, and then explicitly verified which root fit the specific domain of the question. The result? Perfect. Mathematical interpretation and step-by-step relationship extraction are heavily tested. You must prove exactly how you arrived at your final destination.
Let's move to our final section, the absolute pinnacle of exam strategy, the critical analysis matrix, or as we like to think of it, higher-order problem solving. This is where we tackle the highest tier of assessment objectives. These are the elite-level evaluative strategies that absolutely guarantee maximum marks.
The most crucial point when you reach these higher-order questions is evaluating multiple mathematical solutions. Oftentimes, you'll be faced with comparing the similarities and differences of specific outcomes. For example, when you're analyzing turning points using the second derivative test, both a local maximum and a local minimum share the similarity of having a first derivative of exactly 0. But the critical difference lies in the sign of the second derivative. Elite students don't just state that a turning point exists. They evaluate the difference, they support it with mathematical evidence, and they draw an exact conclusion about the nature of that point.
To truly master this kind of higher-order thinking, look at these 4 evaluative elements translated specifically for pure mathematics. Top-scoring candidates demonstrate this by doing these 4 exact things. First, they identify limitations. That means recognizing strict domain and range restrictions when finding the inverse of a function. Second, they question assumptions, like carefully checking whether a calculated angle actually falls within the requested trigonometric quadrant. Third, they consider alternative interpretations. This means recognizing when a seemingly complex algebraic fraction is actually just a hidden quadratic equation in disguise. And fourth, they rigorously justify their decisions with hard, calculated evidence, laying out proofs sequentially so there is literally zero ambiguity. This framework elevates your math from merely calculating to truly evaluating.
All right, we have successfully built your tactical formation. Here is your ultimate mathematics success blueprint. Rule 1, command word decoding. Know exactly whether the exam wants you to solve, verify, or show. Rule 2, apply the PEL framework for logical progression, ensuring your algebraic steps are visible, sequential, and always linked back to the context. Rule 3, the time management matrix. Don't waste precious minutes calculating things that simply aren't required by the syllabus anymore, like properties of coefficients when they've been explicitly excluded. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.
I want to leave you with one final provocative question to think about today. Is your revision focused purely on just getting the correct final answers, or are you mastering the methodical process that actually guarantees the marks? Remember, the examiner's lens is looking for your reasoning, your connections, and your structured execution. Shift your strategy, show you're working, and step onto that exam pitch ready to completely dominate. Keep practicing, keep refining your playbook, and I will see you in the next explainer.